So net change of a function. We've talked about this. We're going to apply it more and more. Okay, we're going to do a couple FRQs today. So we talked about displacement yesterday. Displacement is the change that has taken place over a time interval. So how far are you from your original position? What's another context? We talked about the flies in the jar thing, right? What's displacement in terms of flies in a jar?
Amount of flies.
The change in the amount of flies in the jar. So if there were 15 and 3 flew in and 2 flew out, then the displacement is 1 because 3 flew in and 2 flew out, so there's 1 total. They fell out, yes. The context from the warm-up. What was the context of the warm-up? The displacement was how much water was removed from the tank. Okay? So, more context. How much water was added or taken away? Just like the warm-up. How many more mosquitoes are there than before? Okay? And then one more, let's see. How a plane's altitude changes. So if it was at elevation 2,000, and now it's at elevation 5,000, the displacement is 3,000. But normally I don't give you that stuff. I give you a rate, and I ask for displacement, right? How do you find displacement? The integral of, yeah, from the time interval, but of what function? Of a rate function, right? Okay. So if R of t represents a rate, then displacement, or any one of those contexts, would be the integral from a to b of R of t dt. You guys okay with this? You were all kind of quiet yesterday. So I didn't know if you got it. Do you get it or no? No? What's wrong with this? You just need to see more examples? Position, if we're talking about particle movement, is where you're located, right? What do you have to include when you're trying to figure out where you're located? Your initial condition, okay? So an example of that, let's use the same context here. How much water has been added as displacement? What would position be asking for? How much water is there? How much water is in the tank? How much water is in the lake, right? What about mosquitoes? What's the context there? How many mosquitoes are on the island? This tells you how many mosquitoes, the number of the change in the number of mosquitoes. This tells you how many mosquitoes are left. No, it's not total change, because total change is there were 10 mosquitoes added and 5 mosquitoes taken away. The total change is 15. That wouldn't necessarily be applicable to one of those types of things. It's more position type thing. What about the last one? How a plane's altitude has changed? What would be the context down here? What is the altitude, right? And in all of those cases, you need to know what? So what would you need to know in the first one? How much water you started with. The second one, you would need to know how many mosquitoes you started with. And the last one, you would need to know what altitude you started with, right? So the position, or the context here of any of those, is equal to the initial position plus the integral of the rate. You guys okay with this? Too much writing. What's that? P of A. So because A is your lower bound in both these cases, then we need the initial condition at that time or that time. Yeah, but I'm just giving you more application. Okay? Are we good with this? Going on? Let's look at one example. The rate of potato consumption from 1970 to 1980 is represented by C of t equals that function in millions of bushels per year. That's a lot of potatoes. How many bushels were consumed? I don't know. How many? I don't know. A bushel is what? 100 potatoes? I don't know. The rate of potato consumption is given by C. So C is a what? C is a rate, and you can know that because you can see the units. What's the units on C? bushels per year. So how many bushels are consumed from t equals 2 to t equals 4? What context? What type of problem am I asking for? Displacement. I'm not asking for how many potatoes are left. I'm asking for how many were consumed, so it's displacement. So what's the equation? Yeah, that's it. Displacement. So it's the integral from 2 to 4 of c of t dt, which is? So what's the units on that? Bushels, right? Because the integral of a rate is an amount. So 7.066 million bushels. Because the units here were millions of bushels per year. Wow. That's a lot of potatoes. All right, can I go on? No? Okay. I'm done. So I'm going to give you some time to work on these two FRQs. The one with the title is the front side. So flip it over to the first one. Okay. Let's look at how you did on the first one. Now I know you guys talked a lot, but that's okay. A particle moves along the x-axis so that velocity is given, and it gives you an initial condition. A particle is at position x equals 8 at t equals 0. How do you find the acceleration when I'm given velocity? Yeah. Okay, so it's not asking for average or anything like that. What is acceleration? Take the derivative. What's the derivative? V equals 1 over t squared minus 3, and then times, oops, I'm sorry. Yeah, thank you. I'm all over the place here. Acceleration is 1 over v prime. Going crazy. Okay, 1 over t squared minus 3t plus 3 times 2t minus 3. Okay, parentheses there. So we're looking for when acceleration is at what? 4? So plug that in. So it's going to be 2 times 4 minus 3 on top. And then 4 squared minus 3 times 4 plus 3. This was a calculator problem, so they can't. Well, right, you didn't need it. What was it, 5 over 7? And was there units on this? No units, so that's A. B, find all the times in the open interval at which the particle changes direction. When does a particle change direction? When velocity changes signs. So how am I going to know when velocity changes signs? Set it equal to 0, find critical points. And analytically, you can go through this. Did anybody do this? So equals natural log of t squared minus 3t plus 3. How do I write that? Because this is very well doesn't have to be a calculator problem. Do the hard. Okay, so it'd be e to the 0 equals natural log of t squared minus, no. Woo! E to the 0 equals t squared minus 3t plus 3. What's e to the 0? 1, so I'll subtract 1 from both sides, get 0 equals t squared minus 3t plus 2. And then we can factor that. So t what? Minus 2 and minus 1. So when t equals 2 and 1, does that mean it changes direction there? No, that only means v of t equals 0. What do you have to do? Yeah, you got to check to see what is happening. Yes? To see what is happening. What are you looking for? Changes signs. Okay. So at 1 and 2, we do have endpoints on this, but they're not included. But it gives us values to plug in here. So this is v of t. So if I plug in a half, I don't know what I'm going to get there. Is it positive? Natural log of a positive is, this is where you use your calculator. Look at the graph of the function. What does the graph of the function look like? It dips. Yes, I do. Does anybody have it?
I'm just kidding. No.
Yeah, right. I'm going to walk all the way over there and you're going to say you don't have it. All right. Like this. This is 1 and this is 2. Something like that. And then this is 5. So we see, if we're looking at our number line, this is positive, negative, positive. Is that good enough justification? No. So we would say the particle changes direction at t equals 1 and t equals 2 since v of t changes signs. I'm not going to write all that out, but it's there. And the next thing is, which interval does the particle travel left? Well, when's it traveling left? From t equals 1 to 2 because velocity is negative. Okay, so let's take a look at scores for that part.
It just says, does the particle travel to the left? You say yes.
No, it said when.
No. Oh, just kidding.
Okay, so 1 point for the answer on part A, 1 point for setting v equal to 0, 1 point for identifying the change in directions at t equals 1 and 2. It didn't ask you to justify, did it?
I didn't.
And then the interval with the reason, so the interval would be it's traveling left from 1 to 2, t equals 1 to t equals 2 because v of t is negative there. If you did 0 equals that counts too. Yeah. All right, part C. Part C, find the position. Find the position. What's position? So what is the initial condition? 8 plus the integral from 0 to 2. Was that the integral? Okay, of v of t dt. And so what do we get there? 8.369. Again, no units on this, so that doesn't do anything for us. You got 1 point for the correct integral. So if you said the integral of v of t or the integral of natural log whatever, and then you get 1 point for including the initial condition, and then 1 point for your final answer. So that's a lot of points. You have to understand position, displacement, and total distance problems, or you're not going to get these many points here. Okay? 3 decimals. Yeah, this is fine. Because they stated what v of t was. If they didn't say v of t equals, you'd have to say somewhere if you're going to use v of t what it is. All right. Part D said find the average speed. What was given? Velocity. So there's 2 things to go about. I could do v of, what is it? V of 2 minus v of 0 over 2 minus 0. What's this? This is the average, average rate of what though? Average rate of velocity. So this is the average acceleration, right? I could do this, 1 over 2 times the integral from 0 to 2 of v of t dt. That would be the what? That's average value of what? Of velocity. So this is the average velocity. I didn't want either one of these. I wanted average speed. So how do I get speed out of velocity? This is speed. So the average speed would be 1 over 2 times the integral of the absolute value. So the answer was 0.370 or 1, however they put it. 1 point for the correct integral. So that means you got to have the absolute value in there. 1 point for the correct answer. So add it up and let's see where you're at. Maximum points, huh? And then the backside is the one I'm most concerned with.
Wait, you didn't show units for number 1?
I don't think they gave you any units. So you don't have to put units if they don't say anything about indicate. Even if they give it to you, you only have to put it if it says indicate units. All right. What I'm seeing a lot of in calculus is what I see a lot of in geometry. If I gave you a geometry problem that looks like this, and I say this is 3 and this is 4, find x. Think back to when you first learned geometry, right? You do Pythagorean theorem, right? But then if I gave you the same exact problem, I just rearrange where the variables are. What is a lot of students going to do? They're going to say, oh, I know how to do this. 3 squared plus 4 squared equals x squared. And then they're looking for a pattern, and so they're going to do the same thing here, because what do they see as a pattern, or they're trying to observe as a pattern? That the variable is always on the left, or the variable is always equal to the variable, right? Obviously, this is wrong. So we have to get outside of that, okay, I'm just looking for the teacher to give me a process to solve this equation, or to solve this thing, and do this thing. Just give me the steps to get it done. Because just giving you the steps to get it done doesn't solve the problem correctly. So it's the same problem here. If I give you an equation and I say, what's the rate? What is predominantly, what is everybody going to want to do? Take the derivative, right? But what if I gave you velocity, or if I gave you the derivative? Well, everybody's going to want to do the same thing again because they're looking for a pattern. They're going to want to take the derivative again, right? So try and get away from just looking for basic patterns of procedures and make sure you're understanding this stuff. A. First of all, what's given? It says W is what? It's the rate in. And R is the rate out. This is a very common problem. You got a rate in, rate out problem. How do you find overall rate? Rate in minus rate out. How do you find overall amount? If I give you a rate, how do you find the amount? It's going to be the integral, right? If I take the integral of W, what do I get? The amount that's what? Going in. And if I take the integral of R, that's the amount going out. Okay, so just context here. Is the amount of water, part A, is the amount of water increasing at t equals 15? So if I'm looking for when that value is increasing, the amount is increasing, what do I have to look at? What did you say?
The rate.
Okay, what are you looking for in the rate?
What goes in and what goes out at that time.
Okay, but thinking of the chart, if I want to know if the amount is increasing, that's the same as asking when is the rate positive. And what do we say the overall rate is? Okay, so what are we going to find here? We're going to find W of 15 minus R of 15. And what did you get? Okay. And so what's our answer here? Is the amount increasing? No. And the justification would be since W15 minus R of 15 is what? Less than 0 or negative? What's another way of saying this? You could have said, or since W15 is greater than R of 15. The rate in is greater than the rate out, therefore, sorry, that's wrong. The rate in is less than the rate out, therefore, it's decreasing. You guys okay with that? Okay. Points for this? You get 1 point for the answer. So, no, since.
So finish our work for that. We just get.
Well, it says answer with reason. So you'd have to show, or you'd have to do something that says W15 minus R15 is something. Okay? Is negative in this case. Part B. Is to the nearest whole number, how many gallons of water are in the tank? What am I asking for at that problem? Am I asking for, in terms of the context of motion, am I asking for displacement, position, or total distance? Position, right? So the amount when t equals 18 is what equation? What's the initial condition? 1200 plus the integral from 0 to 18 of what? You could do it like this. We didn't go over any of this, right? Okay. You could have done it like that, or you could have done it like this. Either way works. Of W of t dt minus the integral of 0 to 18 of R of t dt. Both of these are equivalent because of the sum and difference rule, right? Okay. One thing I want to note, though, if that's a multiplication, can you separate it like that? No. Okay. What did you guys get as an answer? Is that right? Okay. And then it did say to round to the nearest whole, so it'd be 1,310 and gallons. Okay. Point values on that guy. You get, this one's kind of cool. You get 1 point for the correct limits. That should be easy points. You get 1 point for the correct integrand. So if you said W of t minus R of t for the integrand, or if you separate it in two, you get a point there, and then 1 point for the final answer. Okay. Any questions on that one? No, you guys are good? Okay. Part C, we are looking for an absolute minimum. How do I find absolute minimums? Do I want to take the derivative? No. I'm looking for the absolute minimum of what? The positions, the amount of water, right? So how do you find the absolute minimum? You have to find all your critical points first, right? Do I have to take the derivative to get my critical points? No, because this is the derivative, right? So I got to find my critical points. First of all, what's the first critical point? Not x equals, I'm sorry. T equals 0 and 18 because those are endpoints. What's the next set of critical points? What equation? The rate. Do I care about the critical point of that? You've got to look at the overall rate. So when is the overall rate, the rate in minus the rate out, equal to 0? Now, if you didn't do this, I want to make sure you're doing it. Okay? Chances are you put this where? In y1, right? And this is y2? Okay? What are you looking for to solve this? Okay? You can go through and say, okay, y1 equals w of t minus r of t. You'd have to type in both those equations. You'd have to plug in w and r, and then you're looking for what in this case? You're looking for the zeros, right? But instead of retyping the whole thing in, I'm going to solve this by saying r of t equals w of t. You type, this is y1, this is y2, because it's probably there, and you're finding the what? The intersections, right? So if you didn't do it, do it. Okay.
So you can graph both at the same time and see what it is.
Mm-hmm. Do it if you didn't do it. It's a good skill to have. Okay, I don't want to dwell too long on that, but you got to look at it that way. So you got t equals, these are your other critical points. Now, how do you find the absolute minimums? Okay. If you do the number line, what are you finding? What kind of minimums? You're finding relative extrema, right? We want absolute. So if you do the number line, whatever it is, let's just pretend I know what I'm talking about. If this is your number line, 12.975, and these are zeros, these are endpoints, these are endpoints, and let's say this is positive, negative, positive. I don't know if it is or not, but let's just say. What does that make this one? A minimum. This one's a maximum, a minimum, a maximum. Does that tell you what your absolutes are? No, it only tells you your relatives. So then what would you have to do from there? You'd have to plug in all those values anyways, right? So it might be better to just evaluate all your critical points.
Is that the case? Should we just do that?
When you're talking about absolute extrema, it's probably better to just evaluate all of them.
And even if there's like 4 points, there's like 4 x values.
Well, yeah, if it gets ridiculous, don't do it that way. But in this case, it's only 4, and you already know 2 of them anyways. So I'm going to create a chart, if that's helpful. When t equals something, what is the amount, basically, is the question. So when t equals 0, when t equals 6.495, when t equals 12.975, and when t equals 18. Which ones do I know?
0.
What's the amount of water in the tank, or whatever it is, at t equals 0? 1200, because that was our initial condition. What else do I know? Which other value do I know? Yeah, in part B, we already figured out how much water was in the tank. So this is 1309.788. How am I going to figure out these values? Same thing as we did here, right? So we're going to say 1200 plus the integral from 0 to 18 of Wt minus R of t dt. And look, guys, this isn't a lot of calculator work because you already did the work over here, didn't you? Yes? So go back to your home screen, scroll up to that equation that you already did, and then the only thing you have to change is what? Oh, that shouldn't be 8. That should be 6.495. You only have to change that number right there, and you've got it. So what do we get for an answer there? Okay. You shouldn't have decided to do this. It can't be negative. How much water's in the tank? -5. What'd you say? 0.242? Can I have somebody confirm that? I'll take that as a no. You got it? Okay. And then for this one, this critical point, be 1200 plus the integral from 0 to 12.975 of W of t minus R of t dt. And what do we got there? That should be done if you already got that. 1,697 point what? Okay, can I have somebody confirm that? Yes? All right, so the question is, what is the absolute? No. What is the question? No. At what time does the absolute minimum occur, right? So that'd be when t equals 6.495. Okay, so let's take a look at points for that. You're going to get 1 point for identifying the interior critical points, so basically setting that equal to 0 and finding these 2 critical points here. You're going to get 1 point for identifying that when t equals 6.495 is the absolute minimum, or that's where it occurs, and then you get 1 point for your analysis, so basically all of this. Okay. You guys okay with this? You're all quiet. Okay. And then part D. For t is greater than 18, water is no longer being pumped into the tank. So that means, what's the rate in? 0. Right? So the only equation that applies now is the rate out. So basically, at t equals 18, they stop pumping water in, and they just let the thing drain out, right? You guys okay with this? The question is, at what time, basically, it's not asking you to solve it, but at what time is the tank completely empty? So what would you need to know? Okay, so how much did the tank start with? Well, at 18, because that's when everything starts over again, right? So when t equals 18, we had 1309.788. That's how much water was in there. What do I have to do now? Subtract what? What's the displacement in this case? The rate going out? So, well, you're going to take an amount and then subtract a rate. The integral of R of t dt. What's the limits? What's our lower bound? 18, because that's our starting point, to k. So that's not an equation. This is how much we start with, minus this is how much we took out over this time interval. What is that supposed to be equal to when we're all said and done? 0. Equals 0 because we want the tank to be empty. Okay, so that's it. It said write but do not evaluate. You see that sometimes. Point values, you get 1 point for the correct limits. So if you went from 18 to k, you're good. And then 1 point for the equation. Notice on theirs, they kind of did solve it a little bit, right? They took the first step. They just added this to both sides. So if it was like this or that, doesn't matter. You guys okay with this? Any questions?